Okay, now we covered the example of using synchronized on an instance method, synchronized on a static method. We covered synchronized statements. Why would you need them? Now, there is a third type of synchronization that does not really involve synchronizing on the Ds object, on the current instance monitor, or on the class monitor. And that's using an external lock. So let's exemplify here. Let's say, for the sake of the example here, I have another counter, which I'm going to call counter2 field, right? That I would like to change, right, mutate independently of this other instance field, right? Okay. I don't want to have to lock on, the instance lock to mutate this field. Okay. So when you have that type of scenario, right, then you can create your own lock, right? Let's just okay, let's just do object a lock, okay, and locks these users to be final. So the reason why, remember what I said initially, that every Java object is a monitor? There you go. So you just need to create an object and you have already constructed you can lock. Okay, so now let me illustrate this example here. Okay, so what I'm going to do is I'm going to do private void, again, an instance method. Where is it? C. And I'm basically going to synchronize, right, on that lock. Okay, and here I'm going to be doing my thing. So let's say, for example, let's grab this guy here, and there you go. So I'm on method C, and I am synchronizing on the A lock instance. Okay, so releasing the A lock instance, and obviously I am updating the counter2. Okay, so that's another use for it. It's a completely different field that does not need to be synchronized, can be synchronized independently, and I'm using a different lock. Okay, so now let's go back to main and let me just show you how you could use this. So let me grab this guy here, and let's call it obviously thread 3, and this guy is gonna call the method C, okay, the one that synchronizes on the A lock. So it's seeking the A lock, oops, and has released the A lock. Okay, and obviously let's start this thread and let's join it. Let's run this example, but before that, let me change the sleep time to say 2 minutes, and I want to set a breakpoint here because I want to show you, in addition to the console, the thread states. Okay, so let's run this. Thread 2 is seeking, thread 1 is seeking. Which one has acquired the lock? Well, T2 was the lucky guy that acquired the instance lock, right? And poor T1 is waiting. T3 acquired the lock as well, a different lock, A lock, right? If you look at the debugger here, and if you look at the threads, you'll see that the T2 was the winner. It acquired the lock and it's sleeping for those 2 minutes. T1 is also trying to acquire the same monitor's lock, but is waiting on the monitor. Okay, and thread 3 is acquired the lock on the A lock object and is sleeping. Okay, let's talk about another property of locks. Locks in Java are reentrant. So let me show you here an example. Let's just mark this method as synchronized and AD. And what I want to do here is that, as usual, I just want to say that this guy acquired the lock, acquired the instance lock, because this is the synchronized method. And obviously, let's just say that this is, sorry, not AD. And then while it has the lock, right, let's say it's going to call the instance method A, right? So this is perfectly fine because the thread does have the lock, because it is executing a synchronized method, but locks are reentrant. So while the thread has the instance lock, it can call a method that locks on the same instance. The locks are reentrant. So let's use, I think for this example, let's just use one thread. We don't need to use all these threads for that example. And that's going to be D. Okay. And just to make sure, D is the one that tests the reentrancy. Okay. All right, let's comment this and comment this. And let's go. So as you see, T1 is seeking the instance lock. It acquired, okay. And this is, not really acquired. It's just the nature of the statements I had there. It had already the lock, and it just perfectly fine went into the other method and just incremented the counter, right? So last but not least, let's talk about a very flexible and powerful way of using Java synchronization without using the synchronized keyword. And that's using the java.util.concurrent reentrant lock that was introduced in Java 1.5. So for example, let me just show you an example here. Create an instance method. And basically I have here, let me create a reentrant lock, qlock, okay. And then inside, you use a try finally block, okay? So you unlock the lock in the finally block, and inside the try, it is where you do your logic, right? So here is where you would do your logic, right? Put logic here that needs to be guarded by the reentrant lock. So now why do we unlock inside the finally? It's obviously, right? It's because if, say, I throw here a new runtime exception, right, or what have you, right, then I need to make sure that this lock will be released, right? Otherwise, we're going to be stuck here, right? All the threads waiting on this lock will not be able to proceed. So finally, putting the unlock statement inside the finally. So as you can see, using this reentrant lock, it's quite inconvenient, right? You have to explicitly call lock, then you have to use a try finally block. Inside the finally clause, you have to explicitly call unlock. So you may be wondering, why would I use such an inconvenient and perhaps error-prone way of logging when I have the very convenient synchronized keyword? Well, to learn about the advantages of using reentrant locks, please watch this next video where I explain you that. I'm Nilton from craftofprogramming.com. Thanks for watching.